Welcome guys, my name is Majd Al-Ghamdi and today I'll be running k-means clustering, which is one of the common unsupervised machine learning technique. So I'll be using Spark application on Cloudera platform. Then let's get started. To begin with, I have already downloaded the virtual machine workstation as well as the Scala IDE, and you can go to this link here. As you can see, scalaide.org, and by clicking on the download IDE you will have to go all the way down. You will have three different links here, and depending on your operating system you will have to download whatever matches your laptop type. I choose the Windows here as I have Windows 64-bit. Now let's go to create our Maven project. So we'll go to Eclipse here. So we will start by going to File and we'll create new project. We have to go to Other and then we'll go all the way down to find Maven. This Maven, we'll click on it and Maven project, then click Next and Next. So for the group ID I will name it Big Data, and the artifact ID I will name it k-means clustering. Then I will click Finish. Now it's gonna take a little bit of time, as you can see here. Now we will have to add the Scala nature. Click right on this, go to Configure, and we will add Scala nature. So now change the directory name, and once we click on this we'll have our directories. We will click right and refactor and then rename it. So instead of Java we'll have Scala. The second one too, refactor, rename, Scala. Then we will also have to change the Scala library. Go to properties, then instead of 2.11 we will use the latest 2.10. Now we will go to pom.xml to edit our independency. Then we will go to dependencies and click add. And as you remember, we'll have to go to our Word file and we'll have to copy this and paste it. The group ID. This is the artifact ID and then the version. Then click OK. So we'll add the other one, which is the Apache Hadoop, and again the artifact ID and then the version. Click OK. So as you can see we have added both. Remember to save this file. After we have saved our dependencies, we're gonna create a new object, which is a Scala object. So we will go to Big Data k-means clustering, then we will click right and new, then other. So choose Scala object, then next. We will name it k-means algo, then finish. Our object has been created for us. Now I will have to go to the Word document and I will copy the k-means clustering code which has been given to us. Then I will paste it here. So this is our code. Copy it and I'll paste it here. There we go. Now let's go over all the codes so we'll get an idea how each code function. I'll be starting with the libraries here. I have added all the required libraries here, as you can see, and the Spark context, which will connect the driver with the cluster. Besides that, I have used the Spark conf library, which helps us define the configuration, and the MLLIB libraries, which enable us to use k-means algorithms. Then here, as you can see, we referred to our object, which is k-means algo, and here we created a new object which is Spark conf, and we set up name as training k-means and then the local as master. Here the text files where we stored our data, as you can see here in the user Spark input file. The first file, which is segment challenge, and the second one, which is text segment. And then the first thing we are going to do is to filter the data set in order to separate the headers from the data. And then we will be splitting the data based on the commas, as you can see here. After that, we will be storing the data depending on the type. Here we are assigning the train file to cc1 and the predict file to cc1. In this code, we will be able to convert the training data to data frame, as well as we will be able to convert the predict data to data frame. And to better understand our data, it will be printed into training data snapshot and also into predicted data snapshot. However, here we'll be mapping our data frame, both the predicted data frame and the training data frame, to RDD, which will help us to run the k-means algorithm. And here we are creating the vectors using training dataset and test dataset. Then we can set the number of clusters and the number of iterations. As you can see, the number of clusters equal 3 and the number of iterations equal 20. So we will be having in each cluster 20 iterations. Then we trained our model with the trained data, and this print each cluster starting with cluster 0, and also it will print the sum of squared errors. In this code, we'll be able to save our output locally in Cloudera. Then we'll be able to load the k-means model into this path for production. Finally, we can predict the cluster of each unknown image identified by a point. So we'll be able to convert the result to data frame in this code. And finally, here we define a set of attributes using case class, as you can see. So here's the name of each column and the type. Now, before we execute this code, let's go to our HDFS file system, and we will create our input files. So we go to View, and then we'll click on File Browser. Then we'll go to Spark, and as you can see, I have already created our input file here. So we click on input file. We have two data text, the test segment and the segment challenge. So let's click on one of them to see our data. As you can see, this is our data here. So now let's go to execute our code. So we'll go to k-means algo, then we'll click right, and we'll go to run as. We'll choose Scala application, and it's gonna take a little bit of time. We'll be waiting. As you can see, it's executing. There we go. Make this bigger. So as you can see, we have 3 clusters in the output console, as we have set our cluster numbers. So we have 3 here. And as you can see here, the sum of squared error, which is computed using the compute cost code. In this output, -1 indicate the position of elements. So in this case, the first position of elements in our output, and cluster numbers are assigned to every row in our data set, and in this case, it will be our test data set. And finally, the trained model is saved locally in the home directory. So let's look to the k-means output folder. This is our k-means output folder, and by clicking on it, we'll see the trained model, then the data and metadata, where the metadata folder has metadata about the trained model and the input data. Hopefully you enjoyed this tutorial, and thank you so much.